Hello, I'd like to take a look at a graph of distance versus time, and we want to be able to find the displacement off that graph. If you've been having trouble reading these kinds of graphs, this is a good thing for you to watch. And so we'll take a look at this graph, and as we do, we'll realize that on the x-axis that we've listed time in hours, and on the y-axis we've listed distance in miles. And so this actual graph is a graph of some cars and what those cars did over time. And as we look at this, the longest any car went was for 5 hours, and the farthest any car went to the very top here of the graph was 120 miles. All right, and so we're going to take a look here. Now, the first question we're going to answer is, what was the displacement of the green car in the 5th second? All right, so we actually should count out the seconds as we do this to make sure that we have the 5th second. So from 0 to 1, there's our 1st second. From 1 to 2 on the x-axis, that's our 2nd second. A second is a length of time. From 2 to 3, that's our 3rd second. From 3 to 4, that's our 4th second. And from 4 to 5 is our 5th second. Okay, so that's the time we're dealing with. So if I go up between 4 and 5 here, I'm going to start at the 4 and I'm going to go up on the graph. And okay, so that's where we have to measure the distance that car started at, or the location that the car started at. All right, and so when we do that, we got to think, oh, what's that small line here? I know it's above 40. All right, above 40 miles or farther than 40 miles, but I don't know how much farther until I take a look here at that y-axis and say, okay, what is each of these little lines equal to? Well, they could be 10, 20, 30, 40. No, that's not going to work. It doesn't say 40 there when I count by 10. All right, and so I need to think, okay, maybe these little lines are 5, 10, 15, 20. That looks right. Each of these little lines must be worth 5, because that ends up at being 20 here then. So now that I know each of the little lines are worth 5, this line right here was 40, but it was about 1 square farther. So I'm going to write 45. Now 45 what? If we remember, that y-axis was miles, and so I'm going to write MI, that's our abbreviation for miles. And one last thing, well, I'm sorry, not a last thing. Yeah, let's figure out where that car is at the end of the 5th second. We have to do that before we can find out how far it actually went. At the end of the 5th second, oh, that's interesting. It's all the way back to the 0 mark as far as the distance goes. Okay, so it was back home. Wherever it started from over here at 0, it's now back at 0. Okay, so 45 miles to 0 miles is how far this car went. So it went 45 miles in that 5th hour. The only thing is we have to write a negative here, because I asked you what the displacement was. And the displacement has a sign. It's a vector. So it's negative 45 miles that this car went. All right, let's check one more. Let's see if we can do the green car for the 3rd second. We already know that the 3rd second is right here. I'm going to go up my graph. 3rd second, at the start of that 3rd second, the car was at 120 miles. And we know that at the end of the 3rd second, that's on the time of 3 line, that car looks like it was about, oh boy, it's about 1 square below the 100, it looks like. Well, remember that 1 square was equal to 5, so that's about 95 right there. Okay, so it started at 120, it went to 95. How far is that? You could calculate this out by taking 120 minus 95 on your calculator, but you might just know that that's 25 miles. And so 25 miles is how far that car went. But again, did it go forwards or backwards? Well, it was going forwards. We would consider it going forwards or in one direction when it was going from 0 to 120. And that means this here, it was going the opposite direction, and it went 25 miles in the opposite direction. So we got to write a negative sign there. So negative 25 miles is the displacement for that car in that 3rd hour.